Hello everybody and welcome back. Root Beer here, and we're looking at question number 6 on the Euclid contest from the year 2002. Okay? So what does question 6 say? Well, it's a two-part question. An A part and a B part. That seems to be sort of common at this point. I think 4 and 5, they were also A and B. With a written, just a final answer part and a written portion. And looks like 7 will also be like that. So we'll look forward to that. But we're taking a look just at question 6 right now. So 6A. In the diagram, ABCDEF is a regular hexagon with a side length of 10. Here we have 10 labeled over here. If X, Y, and Z are the midpoints of AB, CD, and EF respectively, what is one of the side lengths of this triangle? Now it's going to be an equilateral triangle. That is something we can say for sure. Just because it's inside a regular hexagon and it's constructed with a high degree of symmetry. Okay. Oh, I'm noticing there are trapezoids, like AXZF is a trapezoid, so that might be of some use to us. But let's draw the picture and see what we can see. Things to note will be that a regular hexagon has an interior angle of 120. That's important. Let's see if we can draw a hexagon properly here. Close enough. Okay. So we have A, B, C, D, E, F, and I think we had X, Y, and Z, and we know that all these side lengths are 10. And we can actually say that CY and CD, and YD are going to be 5, because Y is the midpoint, so it splits the whole length of 10 in half. Similarly, we're going to have lengths of 5 up here and here. We just label everything that we know. Alright. Other things to note, and we'll switch colors for this. We have an interior angle of 120 degrees up here. And our triangle is going to be equilateral, as I already remarked. So we're going to have 60 degrees here. Now, whatever this interior angle is here, it's going to be the same as this angle up here, and this angle here. And by symmetry, it'll be the same as this angle here, and this angle here, and this angle here. Just because it's a very symmetric construction, I should be able to sort of flip it. What would you say? Flip it across a vertical axis and get the same picture. So these angles should be the same here. Okay, so that's our reasoning here. A lot of symmetry in this picture. We can say all these red angles here are equal. Okay. Well, our red angle, so I guess we could say angle AXB, but it's a full line, is 180 degrees. But it's equal to angle ZXY, which we know is 60 degrees, plus angle AXZ, plus angle BXY. And that's 60 degrees plus 2 copies of our red angle. And it doesn't take too long to see then that our red angle is going to have to be equal to 60 degrees. We can work that out separately. So we have some 60 degrees, we have 120 degrees, And I think I see where we're going with this now. Let's just take a look. Let's just zoom in on the trapezoid that I mentioned earlier. A, X, I got an F over here and a Z. So this angle here is 60 degrees. Same with this one. And if we are going to, if we just drop perpendiculars down here, we see, oh, well, we've got a rectangle here. These guys will have to be 30 degrees, and that gives us the total 120 degrees at angle F. So we get a rectangle, and opposite sides of a rectangle have the same length, so that means this is going to be 10. And we know each of the hypotenuses here of these triangles are going to be 5, but it's a 30, 60, 90 triangle, which means that this side length over here is going to be a half of the hypotenuse. So 5 over 2, 5 over 2. So xz, I think it was xz we want. If it was xy or something, it'll be the same. So 5 over 2 plus 10 plus 5 over 2. Well, these two 5 over 2s are just going to make a 5 plus 10 gives us 15. And we did want xz, although it's the same xz, xy, yz. They're all the same, but they're all going to be 15, and that's the important thing. So, good to know. Alright, that does it for A part. We did show our work, despite only needing a final answer, so if you could make if you could jump to some of those conclusions a little quicker, more power to you, really. Okay, B part. We need a written answer here. A circle passes through the origin, and the points of intersection of the parabolas y equals x squared minus 3 and y equals negative x squared minus 2x plus 9. Determine the coordinates of the center of this circle. Okay. So we're given 3 points here, and 3 points are always enough to determine a conic, be it a circle, an ellipse, or a parabola, or even a hyperbola. So we have 3 points. We have the origin, and we have the points of intersection of these two parabolas. And I'm betting, even though I haven't drawn it yet, I'm betting that these two parabolas intersect at 2 points rather than, say, 1 point. 2 points at least. If they intersected with 1 point, then we'd only have the origin and that 1 point of intersection, and that wouldn't be enough to even tell you what the center of the circle is, because there'd be multiple circles that pass through those 2 points. Okay? But let's talk about the intersection of these parabolas. Let's figure out exactly how many points they intersect in and where those points are, because that will help us determine where the circle passes through, and that'll help us get the coordinates for the center of the circle. I'm going to start on another page. So first let's find the points of intersection. That's points of intersection, not principle of induction. I know the abbreviation can be found with both of them, but points of intersection of the parabolas. So we have our first parabola. It's a very simple formula, that's why I can remember it quite easily. X squared minus 3, and then the other one was we had a negative x squared, and then I think a minus 2x. But let's just go back and make sure. Minus 2x plus 9. Okie dokie. Okay, we could probably, if we wanted to, convert the second one into vertex form. You'll notice the first one is in vertex form. But I don't see any need to do that right now. We're not graphing these yet. We might not graph them at all. We just want points of intersection, so let's equate these two. X squared minus 3, negative x squared negative x plus 9. We'll bring it all over onto the left-hand side. We'll get a quadratic that we can solve. So x squared, and then we bring over this x squared. We'll get 2x squareds over here. Flip the sign here, so we get plus 2x. And then negative 3 minus 9. That'll be negative 12 equals 0. One thing I can do is I can divide both sides by 2. That doesn't change the 0 over here. But it does make this parabola slightly easier to work with. X squared plus x minus 6. Okay. So, if we solve this quadratic, we'll get the x coordinates of the points of intersection. We can already suspect that since we're looking at a quadratic, we'll get 2 different x values. That'll give us 2 different y values, and we'll have 2 points of intersection. So, we need to go about solving this quadratic to get our x coordinates. And you can either solve them in your head, guess and check, or you could factor it, or you could use the quadratic formula. I always try and recommend the quadratic formula. It can sometimes be a little longer if it's a very quick quadratic to factor, but it's consistent. You don't want to spend a lot of time sitting there trying to factor something in your head. So I'm going to factor it, but I encourage you guys to practice your quadratic formula skills, because that one is consistent. That always gives you an answer. Whereas sometimes it just might not factor easily. So I want 2 numbers that multiply to negative 6 and add to 1. So I'll multiply to negative 6. Well, what numbers multiply to 6? I'm thinking 1, 6, 2, 3. Those are nice integers that would be a good factorization. One of those will have to swap a sign, so maybe 2, negative 3. Well, what do those add up to? Those add up to negative 1. So instead, let's say x minus 2, x plus 3. Negative 2 times 3, that's going to be negative 6. Negative 2 plus 3, that's going to be the positive one we seek. So we have roots of 2 and negative 3. And then, what do we have here? 2 and negative 3. Okay, so now we want the actual points of intersection. So pick either one of these parabolas and substitute them back in to get your y value. 2 squared minus 3, that's going to be 4 minus 3, that's 1. 3 squared, negative 3 squared, sorry. Negative 3 squared minus 3, that's still going to be 9 minus 3. That's going to be 6. So our points of intersection are 2, 1, and negative 3, 6. So we remember what we're asked for. We want the center of the circle. Passing through, remember it was the origin and these points of intersection. Okay. Well, how can we do that? Well, I suppose the easiest way to do it is all circles have the form x minus h squared plus y minus k squared is equal to r squared, where h and k are the center. Or hk, I guess, is the center if we want to be grammatically correct. And all these points should satisfy what we've got here. So we have 3 unknowns, the hk and the r, and we have 3 points. That'll give us 3 equations. So let's go ahead and plug in our points. 2 minus h squared plus 1 minus k squared. If I have made a mistake, I'll find out in a moment when I go back to double check. Okay. So let's just, we'll go back and double check what we've got going on here. 2, 1, negative 3, 6. Okay. So we can clean some of these equations up. For example, the first one really quickly becomes h squared plus k squared is equal to r squared. I'll call that 1 prime. Now what we can do is we can I guess we can just expand number 2. I was trying to see if there's anything clever we could do by equating some of the equations. Like letting 2 and 3 equal to each other, or let the left-hand sides of 2 and 3 equal to each other because they're both equal to r squared. That's certainly something that could be done. 1 minus 2k plus k squared is equal to r squared. I'll call that 2 prime. And then on the bottom, or the last one here, we'll expand out 3. 9. I guess it'll be plus 6h plus h squared plus 36 minus 12k plus k squared is equal to r squared. And we'll call that 3 prime. Now something we can do is using equation 1, we know that h squared plus k squared is equal to r squared. So h squared plus k squared, that's the same as r squared. We'll get a 0 over here. H squared plus k squared equal to r squared. We'll get a 0 over here. And let's simplify. The 4 and the 1 become a 5. 5 minus 4h minus 2k is equal to 0. 9 plus 36, that's 45. Plus 6h minus 12k is equal to 0. Now we have 2 equations in 2 unknowns, the h and the k that we want. So if we just solve these, figure out what h and k are, we're going to be all set. So one of the first things I know, I can divide by 3, the second equation, and I'll get 15 plus 2h minus 4k is equal to 0. And what else do we want to do here? Well, we can always solve for, let's take this first equation. 5 minus 4h. We'll bring the 2k over to the other side and we'll divide by 2. At this point, it's really however you want to go about solving these 2 linear equations. Whatever you want to do is fine. And we'll sub this into our second equation. Minus 4. 5 minus 4h over 2. That's got to be equal to 0, so let's expand that and simplify it. The 4 and the 2, we'll just be left with a 2 on top, so negative 2 times 5, that's negative 10. Negative 2 times negative 4h, that's plus 8h. And 15 minus 10, that's going to be 5. 2h plus 8h, that's going to be 10h, is equal to 0. So 5 is negative 10h, or h is negative 1/2. Well, now that we have h, we can substitute it back into this formula up here and figure out what k is. 5 minus 4, negative 1/2, all over 2. So 5 minus The -4, the negatives are going to cancel out, so it'll be 5 plus, and then 4 times a half is 2. So that'll be 7 halves. And we can say that the center now is -1/2, 7 halves. Okay. Now I'm going to stop there. But if you had time on the competition, what you could do is take this h and this k and plug them into that 1' equation. Figure out what r is. Because h squared plus k squared is going to be equal to r squared. You could work out what r is. And then you would actually have the equation of the circle in its entirety. And you could actually go and plug in 0, 0 and make sure it works. And 2, 1 and make sure it works, and -3, 6 and make sure that works, just to make sure that you do. You know what? Actually, I will do that. It's a YouTube video. I have the time. Yeah, and it's important to it's important to check. So why don't I check now? So hopefully r squared will be kind. R squared -1/2 squared plus 7 halves squared. So that'll be 1/4 plus 49 quarters. Oh, I already don't like this. 50/4. So r is 5√2/2. Right, we square root that, which means we square root the bottom. So square root of 4 is 2. And the square root of the top, well, that's 2 times 25. Square root of 25 is 5. And square root of the remaining 2 is √2. So that's what r is. So, and remember, we're just checking. We already answered. We gave our answers to what we thought the center was. So our circle is x. It would be minus, but it's minus -1/2. So we just say x plus 1/2. Plus y minus 7 halves squared is equal to 50/4. All right. Now let's make sure that this works. So obviously 0, 0 is going to work. That's the equation we just used. But 2, we'll check the other points. So we'll check 2 plus 1/2 squared plus 1 minus 7 halves squared equals 50/4. We want this to be true. So 2 plus 1/2, that's going to be 5 halves, all squared, plus 1 minus 7 halves. That's going to be -5 halves squared. That's going to be 25/4. Plus 25/4, and that definitely equals 50/4. So that one's correct. And now the last one, this is the final one we need to make sure. 1/3 plus 1/2 squared plus 6 minus 7 halves squared. We want that to be 50/4. -3, that's -6/2. So that becomes -5/2. Squared. And 6, that's 12/2. So 12/2 minus 7/2, that's 12 minus 7, or 5/2. And that's the exact same. This also works. So we did our double checking. We made sure that it works. You shouldn't do that until the end of the competition. You don't want to waste time checking unless you're really insecure about your answer. You think you made an arithmetic mistake somewhere. You don't want to check until you've sort of done as much as you can on the problems on your first go-through. So you should try the competition, go through 1, 2, 3, 4, 5, 6, maybe do 7 and 8 if you can, and then, oh no, I got stuck on 9. Well, I'll cool off, let my brain think about it for a moment, and I'll go back and double check maybe 5, 6, and 7, and 8 just to make sure I did them right while I have the time, while I'm sort of stalled. And then we go back and we try 9 and 10 again, and oh, well, we can do 10A, but oh, 9's still a mystery, and there's no way I'm doing 10B, that sort of stuff. But don't just jump to always checking. Checking can be a lengthy process, especially if you're confident in your answer. Time management is a very important thing on a contest like the Euclid. So checking, important, but not more important than getting more of the questions at least looked at. Okay, and that does it for question number 6, I think it was, on the Euclid 2002. So we're actually going to move on to question number 7, another two-parter, but we'll take a look at that in the next video. So thank you guys for watching, and I'll see you next time.